This is video 10.1.2, and the goal here is to be able to simplify rational expressions involving multiplication and division. So you've been simplifying rational expressions, but now we're going to move on to dealing with ones that have multiplying and dividing. So here's a couple of important things that you need to remember. That when multiplying fractions, it's as simple as multiply across top and bottom. So it's just one big multiplication problem across the top and bottom. And we'll see that in just a second. The next thing you need to remember is that what happens when you divide fractions. And when you divide fractions, you change it to multiplication. So that's the good news. The multiplying is easy to remember, but the dividing is a little bit harder. And when we divide, we change the problem to multiplying by the reciprocal. So remember, that means if I have a problem that said this fraction divided by this fraction, I change that to multiplying, so it's still going to be a over b, but it's going to be multiplying by the reciprocal, d over c. So notice that that's what changed, that the d and the c switched spots. That's what reciprocal means. We flip the fraction. We've seen reciprocal in perpendicular lines this year as well. But when we divide fractions, we change to multiplying by the reciprocal. Okay? So the good news is we know multiplying, we can do division. We just have to remember this one key thing. So here's going to be our steps. We're going to start with this example that you see here, and there's going to be two steps. The first step is to perform the operation. And what I mean by that is you have to multiply or divide. So in this problem, it means I'm going to multiply out these two fractions. So what that means is I'm going to do x squared, 5x, plus 6 times, so to show multiplication, I'm going to do times the top. Because multiplying means multiplying across the top. So these two tops are going to be multiplied. And again, the two bottoms are going to be multiplied across the top and across the bottom. Okay? That's step one. So get it into one fraction. Step two, simplify the result. So remember, when we simplify, this is something we've already done. We first factor, then find ones. Now when looking at this, it is partially factored, but is it completely factored? So the top, this first piece right here, is a factor times this piece. But could I perhaps factor this first piece a little bit more? Could x squared plus 5x plus 6 be factored? And the answer is yes. It's going to be a generic rectangle with x squared, 6, and I'm just factoring that first factor. And it has to add up to 5x, but multiply to 6, x squared. Well, thankfully, this is going to be a quick one, because I know 3 times 2 is a product of 6, but a sum of 5. And now I can finish up my rectangle. So this first factor is going to be replaced with x plus 2 times x plus 3 because of the factoring I just noticed here. So the top is going to be x plus 2 times x plus 3. And then I have that 4x. I'm going to think of that as 4 times x, because that's what 4x means. That way I can see all the different pieces here coming together. Okay, so that's the top, but I also need to do the bottom. So in taking a look at the bottom, once again I'm going to start by performing step number 2 and simplifying by factoring. So I look at this first factor and I think, can I factor that more? And hopefully you see they both have an x, so they can be, and there's only one x in each of them, so I can factor out an x from the sum x squared minus 4x. So I'm going to see that this will be x times x to give me x squared minus 4 plus negative 4x. So I'm going to have x times x plus 4 minus 4. That's the same as x squared minus 4x. So that's going to go in place of that first factor, and I'm going to have x times x minus 4. Okay. Now I need to think about the next piece. Now I ask myself, could this be factored any further? This x plus 2 piece. And I see no common factors, and x and 2, there's no way to factor that. So x plus 2 is factored. Okay? So I factored, which is part of my second step here, but now I need to find the ones. So I'm going to find these ones that appear on top and bottom that make a 1. So I see 1, 1, I see the x plus 2 and the x plus 2 down there. I also see the x's. They happen to be on opposite ends of the problem, but that doesn't matter. I could rewrite this problem so I could really see the ones. Put the 4 up here, and I could rewrite this problem so I can really see the ones, because multiplying can be done in any order. Then I can see a 1 here, I can see a 1 here, and on top I have left these two factors, and on the bottom I have this factor. You can see that if I would have rewritten it as well. These would have been the pieces that did not make a 1. So on top I have 4 times x plus 3, and on bottom x minus 4. Now it's really tempting to try and cancel maybe the 4 with the minus 4 that you see here, but these two 4's do not make a 1 because this 4 is involved in a subtraction. And the only time we can find a 1 is when the 4 is involved in multiplication. This 4 is involved in multiplication, so that's good. I could cancel that 4 if there was a 4 on the bottom that also was being multiplied, but on the bottom it's being subtracted. So it is not a factor that can be created into a 1. This is my final answer. This 4x plus 3 and x minus 4 on the bottom. This is the final answer for the problem. Okay? So you are finished because it's as simple as it gets. Much simpler than what we started with. Think about what we started with up here. So let's take a look at the next example. The next example, same first two steps that we see here. Same first two steps where we're going to multiply, we're going to perform the operation, then we're going to simplify. So in this case, though, I have division. So if I want to divide two fractions, I need to change the second one to multiplying by the reciprocal. So I flip the second fraction, and I leave the first fraction alone. Now I can write this as one big fraction with my two factors on top and my two factors on bottom. Okay, so it's one big fraction because that's how you multiply two fractions. Now I look for ways to factor. So let's take a look at this first pair of parentheses. This right here can be factored because they both have a common x. So again, I see that common x, I pull it out of the x squared minus 2x, and I see that x times x would give me x squared, and x times negative 2 would give me the negative 2x. So the top, so far, can be factored into x times x minus 2. And I still have this other factor that was originally here. So it looks like I have two x minus 2's. Okay, don't forget that original factor that was already on the top. Now we're looking at the bottom. We want to factor the bottom before we can find our ones. So on the bottom, I have x squared minus 4x minus plus 4. I'm going to think about factoring that, and I think I have x squared minus 4x plus 4 can be factored further. So I'm going to factor it. Let's see, it has to add to negative 4, but multiply to positive 4. So that means it's negative 2 and negative 2. And I'm going to fill in my generic rectangle. And I fill in the outside because I'm looking for the factors. and I see that this bottom piece can be written as x minus 2 times x minus 2. That's what this first parenthesis can be written as. 4x squared, well, that's a single term. It actually already is written as a product. It means 4 times x times x. That's what 4x squared means. Remember, x squared is x times x. So I see some 1's that are creating. It looks like we have quite a few 1's. We have a 1 right here. We have a 1 right here. And then, if you look, if I think of moving this x over to the other end and erasing the x that was at the beginning, just so I can see it more organized, I can see another 1 right here. So I'm left with stuff on the bottom. These two things are on the bottom. I have a 4x on the bottom. Remember, that was being multiplied. But there's nothing on the top. So remember, when there's nothing on the top, we don't put 0, we put 1. Because all of those things that disappeared created 1's. These all created 1's, which mean it really says 1 times 1 times 1 on the top, which just means 1. So on the top you have 1. This is the simplified result. So all of this turned into this. These are equivalent statements. Okay? Now remember, we didn't consider what x cannot be, but we are going to go back and do that later. So hopefully you're showing your work in these problems. Okay? Because at the end of these problems you're going to try and figure out what x cannot be. So your next problem is one to try on your own. So see if you can follow the 2 steps. So start by performing the operation, the multiplication that's described here, and then see if you can factor and find the 1's. At this point, you should pause the video, and you should do this problem on your own. Okay, I will show you some of the results in partial form, and if you didn't get the same answers as me, you want to make sure you ask your teacher because you want to get the right answers and understand how to do this math so you're successful on your future tests. So pause the video and re-watch when you're ready to see if your solution is correct. Okay, hopefully you're ready to see your results and you've tried this problem on your own. I didn't show all of my work, so that's where you want to ask your teacher if you didn't get the same as me. But I'm at the point where I'm noticing my 1's, and I'm seeing the 1 that appeared here and here. By the way, know that it's color-coded so you can see if your factoring was correct. And you should have just multiplied across the top, and everything on the top stayed there, everything on the bottom stayed there. And then I factored. I do see one more 1. I see this and this would create a 1. So those will also create a 1. So my final result is very simple. It's just x plus 3 on top, excuse me. And on the bottom is x minus 4. And there's my final solution. Now remember, you cannot cancel out your factors where the x's are here. These do not make a 1. Okay, they do not make a 1. Because this is written as, on top we have a plus, which means we have a sum on top, and a subtraction on the bottom. There is no multiplication going on. The only time we can cancel is when we have factors that are the same, and factors mean multiplying. So this is your final answer for that problem, and hopefully you were able to factor and multiply across the top and bottom on your own. Okay, your goal is to finish the rest of the worksheet, the additional problems that are there for you, and make sure you're asking your teacher if you get stuck or have questions. Okay, if you finish early, your goal is to go back and determine what x cannot be for the first 6 questions on your assignment. Okay, these are the first 3, and then the other 3 that that you're going to do completely on your own. Okay, so examples 1 through 3 here, and then the 4 through 6 that you see in your worksheet. Okay, be sure to ask your teacher lots of questions if you don't understand or if you need more help.